As you all know, Tata Steel has got more than 10 million ton capacity. Today, the new plant in Odisha, which is being added, which will also become 10 million ton soon, but at the moment it is producing around 2 million ton. So almost 12 to 13 million ton is the production, and in that, there are many brands. You must be using many other brands like Tata Tiscon, which is very popular brand for the construction segment. That other apart, you have Tata Shakti, Agrico products, and Veron, etc., particularly for the construction sector, apart from auto industries. And we actually, as a tubes SBU, strategic business unit, and we are about 500,000 ton of tubes of various types. Actually, there are a couple of applications. Like conveyance tube is that water supply basically, or plumbing, irrigation, etc. Then we have for automobile. Which is basically for the two-wheeler or four-wheeler industries where tubes have got many applications. I am looking after, I'm heading the business of Tata Structura, which is, relatively, I would say, new, maybe just 2 decades. As Tata Steel almost more than 100 years. So, and tube itself is more than 60 years. So, but then we have become actually #1 vertical in the tube industry today, among our portfolio. Well, that's it. Actually, we are doing almost 50% of the total production of the tubes, that is 250,000, and we have very ambitious growth plan, and every year we are growing more than 30% to 40%, that kind of level we are achieving, mainly in the structural tube market. And today I'll be talking, Tata Structura is part is the steel hollow sections, and very recently we have launched also another product portfolio, that is H and I beam plate fabricated in our factory in Jamshedpur, which is also supplementary probably for the structural application along with the tubulars. Well, many things we learn from nature to implement some of the application areas. So tube also probably we learn from application of the bamboos. Bamboos have been sadiyo se, like ages we have been using for some kind of structures, maybe decorative structures also. Even today, some of the architects still prefer. I know that Vedic village in Calcutta, which has got a conference room and all, it is about a decade old, and they have just very nicely used this architecturally as well as structural application. So it is something to really note. Okay, so from this hollow sections concept, probably tube for structural application has made waves in the international scenario, but we were lagging, so to say. Entire my career, I was fascinated with tubes, and then slowly we could, what we thought more than 2 decades back, today it has come to reality. So from circular pipes to square, then to rectangular. So this is the kind of journey. And what advantages from structural point of view, we have got twofold. One is that we go for the material savings, basically from the geometry of the section, the sectional properties like your I, R, etc. for the structural engineers. So here, even in tension, compression, bending, shear or torsion, these are the 5 basically characteristics of the structural designers which they look for. And tensile capacity, L, even hollow section, if you compare with the conventional, particularly for lattice or design of truss, etc., where the connections require for angles, particularly you require a lot of holes for gusset plate connections or the understand leg of the angle. So that reduces the total capacity to almost 15% as per the code. So here you can take hollow sections, full kind of cross-sectional area. Similarly, for the compression, we have L by R, where L is the fixed, whereas R, which is radius of gyration for the hollow section, that is the highest given the same per cross-sectional area per meter weight. So, and therefore, L by R, that denominator becomes more, and then actually L by R values reduces, thereby compressive strength will be more, keeping the cross area. Similarly, in bending, full strength under bending moment regardless of lateral resistance due to superior torsional rigidity. Particularly for biaxial bending, hollow sections will be in bending, it will be acting quite efficient and you'll get advantage. Well, CR capacity is higher because two waves are given, so more than 70% of the cross-sectional area will be effective for the CR. So torsion, of course, this is highly useful. Basically, hollow sections give you the maximum torsional resistance, and therefore, particularly today, earthquake design, etc., definitely will recommend lightweight, even torsional rigidity high. So this will be a product. These apart, you have architectural advantages, or that is high quality surface finish. It is really a dream. I think many projects will definitely call for the kind of sections that is today available. And I mean, architects or engineers will be looking for this product. As you rightly said, probably our education system has to change a lot, and I fully agree with you. We are at Tata Steel, in our way, with its deck, etc., we are doing architectural competition, where a lot of such projects have been initiative, all India basis. Today, the awareness is phenomenal, but there is a long way to go. That apart, you have exposed application can become the exciting and visual part of the design, as is mentioned. Cost effective, ability to conceal essential services through the, in UK, there are a lot of steel buildings basically, and all the services, like whether it is the plumbing services, electrical services, those are concealed through the columns which are used, hollow sections, even in the beams as well. And fabrication, actually, ultimately, mostly it is node-to-node connections, particularly the trusses and girders where there is lattice, and therefore, there is a lot of reduction in the cost of fabrication. Painting surface area goes down because inside you are not painting; it is automatically gets sealed and is not required really. Then reduced weight means cost of transportation. These are all indirect way of saving, ease of fabrication and erection. These are also to be considered, and therefore the costing goes down ultimately. Tata Structura is available in 4 grades: 210, 240, 310, and 355, according to IS 1161, which is circular primarily, and IS 4923, which is square and rectangular. In fact, the new addition is 355 in the IS 1161 as well as 4923. And this grade is actually, we are just probably thinking that we are catching up internationally, the grade, upgrading ourselves. But right now, in fact, international grade has come up to 420 MPa in tubes. Because tubes is again, unlike steel plates, etc., it has to be, rolling capability, etc., and the acceptance in the market. And already it is a thinner section, so again to reduce to what thickness possible, probably 355, we thought that it is a good sort of grade. Sizes, Tata Structura has got up to 300 millimeter in circular and square 250, 250, and rectangular 50, 25 to 300 by 200, and up to 10 millimeter in thickness. Well, I've just taken some comparative study. You see, one is that because of grade, it gets saving of steel. Apart from the sectional properties, there are 2 aspects basically. So here, if you see some up to 18 meter span truss, we find that there is almost only truss kind of design. It is only almost 47% saving as compared to a 6 meter span which we have taken in the tubes as well as hollow sections as well as angle channels. One is 2.4 metric ton, another is almost 1.275. So there is almost 47% saving has been established. So this is just conventional sections versus tubular section. Another case study which we have taken, again 310 versus 355, and we have found that there is another, it is very, saving is around 12 to 13%. So from grade also, directly you can say approximately 310 versus 355 is around 12%. So that is the kind of achievement is, in fact, more achievement has happened in this truss, which is some 40 meter span. And in fact, large dia will be, higher grades will be used for the larger sizes and larger thicknesses. So only thing that we got to know in the marketplace, there are various tubes available because it is a, people are not aware much, and therefore that what is the real grade of tube, so that to be used for structures. It has got something CE, that is carbon equivalent, which should be, it's a formula, it is shown in the slide. So if it is up to 0.35, that is excellent, and below that actually 0.5 and all that poor. So you sometimes you see that actually welding failures in the tubular structures, there is complaint. And yes, I do agree. So this is the kind of material has to be used. Never, I mean, re-rolled material has got possibility of such cracks. I'll just show you some of the things which we started from the beginning, some industrial shades, which is more today with the PEBs. In fact, there is a huge demand, but still there are some places where such truss system is being used. Maximum recognition had come after probably the tubular structure had been accepted in India by all consultants and architects once the airport project all over the country has started off with the tubular. So this was Amritsar airport, and similarly there is about 40 odd airports which had come up so far, and everywhere Tata Structura has been used by the engineers and the architects. Similarly, then we have actually approach to the railways. Slowly, railways are changing. It is again a huge mammoth organization, various zonal railways. So we have been successful many places, and we are still going on. So probably there is a huge future for the railway stations, and we'll continue to do that. These are under Sidco railway system in the Bombay, where it is more of the private than to the government, where they could explore some of the exciting design. After that, actually, we came to the stadium. Commonwealth Games, most of the stadium before that stadium in a way, but then at least 9 stadiums projects in Commonwealth Games has used Tata Structura. And since right now also we are doing with Noida Cricket Stadium, International Stadium, Lucknow Stadium. So there are many such stadium projects which is going on with Tata Structura. This is Tagraj Sports Complex. This is Velodrome during Commonwealth Games. Now, coming, these are the sectors. We wanted to go to explore other areas wherever is possible. This exhibition, mall, and convention center. This is the large span. See, column-less 80-meter to 100-meter span was a dream at one point of time, I know. But today, it is just the confidence which probably structural engineers has to have, and it is there. I mean, we are just the facilitator. Today, this is Saurabh had just talked about the Patna Convention Center. We are proud to be associated. I think we have not let you down for 3,000 to 4,000 ton of tubes that had been used through Aluwali, of course, was by. And it was really a marvel piece, I could say, today in the country. See, it is endless. So it is a thinking. I was just wondering, one of the consultants from Indore had designed a bridge. There are, other bridges where bracings are used in the railway system also, I know. But I think we Indians have got some sort of, for Hardwar, that kind of religious kind of avenue. So our material is used such a religious place where a bridge like arrow or bow has been created. Fantastic, I'll say. Now, my focus area was last 1 or 2 years with the sector which is like power sector, where conveyor structures or the pipeline, for the EIL, etc., where the pipe racks are used. So those are the possible areas. So we have been successful. See, power sector, the conveyor structures, material handling, etc., we have been able to do it. See, all you see is that tubular galleries as well as stringers. So these are various companies who were giving turnkey projects to the power plants. Our own project, which we always depend on our consultant, incidentally, Dastur. It took us a long time. We cannot just say we produce and you have to use. So they had to be convinced, and in particularly last 5-7 years, that whatever project they are doing, they are using. And this Odisha project, particularly for the conveyor structures, as you see, out of almost more than 1 lakh of ton total structures, so 20% was hollow sections. So we want to just showcase as well. I mean, our own projects to that it is used. So in Jamshedpur, in Odisha, wherever this kind of pipe support structures are required, so apart from conveyor structures, so these are used. Well, NTPC, as I mentioned, we have been working 3-4 years down, last 4 years or so, and we have been able to today, in fact, all NTPC project, they recommend their own mind, and they use tubular steel also as an alternative sections. So it is a EPC contract where design. First, they started with conveyor galleries, particularly for the coal handling plant, and later on, these many projects are there. So some of the, even BHEL being the big power plant player, so they are using for conveyor structures and the boiler house, some bracings, etc. In pipe racks. These are the places where could be potential. Not necessarily it has been used. It is in the design stage, somewhere it is used. So then in power transmission also we have been trying. China has proved that this kind of design for the TLT as well as substation structures is a good opportunity. So we are working with Power Grid, and partially we hope that next few such projects would be coming. And there are lot of substation structures, again, lot of RCC structure being replaced with the steel structure. So something called valve hall, where it's a huge height and 40-meter kind of height and on that. So this is possible. In power sector, again, solar industry is a very, very big industry, is a big dream for country, and there are many places hollow sections are used. Though they are going many cases, particularly PV technology, coal form sections, but NTPC is allowed probably some thicker section and hollow sections they are recommending. In tubular telecom towers, particularly now that 4G, etc., with the company, Denmark-based company Ramble, with we have been our partners, and we are supplying a lot of such high tensile struct tubes for application of their mass. So as I was just mentioning, more than 100-meter span. Today, I think it is 120-meter also has been designed, and this is for the various raw materials, particularly cement industries or coal industries. They have to cover because of the Environment Ministry's directions, and tubes are being used for such large span structures. Like this kind of, earlier this coal used to be just kept open in the power plant, and it is today that during the rainy season, it gets wet and then the efficiency goes down. So there is and that apart, in the summer again it is a pollution. So both the aspects, so these are the scope for large span coal storage, coal storage sheds. Yeah. So similarly, this fertilizer plant, they have a huge structure which is 40-meter again height. But then beautiful thing is that the conveyor structure is called silos. So conveyor structure is just hanging from the roof of the structure, and this is a silo for IFCO. So apart from that, the design which could be followed for the large span warehouse sheds could be lighter, and it probably my previous speaker was saying that many of the PEB structures actually is so light, so probably you have to make a balance, and in the design probably combination of all sections would be more useful. Now that there is, we are working with the EWS, a lot of low-cost housings projects. So this is one such project which is being used in some mining areas. That apart, we have got, you architects, you have responsibility for various grills design, ballasts, etc., which is used in the building sector. So quality tubes people did not know. So there is to be raw material which is from re-rolled sections. So those are being used. So as I told you earlier, your welding could be a factor. So this is the kind of proper graded material has to be used. So this is what, the railings, etc. is talking about. So that apart, there are a lot of architectural buildings. So some of them international though. So application is endless, innovative design, some free flow structures. So you get a lot of scope to do that. Malls, of course, today they're exposed with steel structures and tubes are always being used. Uh, Exhibition center in Mumbai, some skywalk shapes. Bombay has got a lot of skywalks, and these sections have been used in various shapes. Here also in H1, we have got a lot of FOBs. Soma Builders was the contractor, so they have used with this product. Nowadays, a lot of heritage buildings are getting, getting renovated. So is the few cinema halls in Kolkata. So it has become a mall, kind of small mini malls or so, mini market. So keeping their business intact, things have been changed. So some international touch, I think we have to reach somewhat like this touch. We are almost going very close. So this is the kind of structures they are doing with tubes, hollow sections. So this is Dubai Metro. There are many such. I think we have, even a food bridge could be so exciting. So probably we just, I'm just seeing that there is some changes have come in part of Delhi, but there is some more to go. This apart, we have got a structural tube. Somebody was just discussing about the fire. So we have got a fire resistant structural tube as well. So it's a little extra cost. And then we have, 2 hours fire rating at 600 degrees centigrade, etc. I mean, this is also available with similar this 355 grade possible. So this is, what is the initial fabrication, bending, etc. is possible with the tubes. Today there is a lot of international players who are supplying machines which can be used for profile cutting. That was one issue. So this was kind of joints. And this is some basic connections. I think in the space frame area, this latest I saw is the trioditic joints. Probably we have to think of. Well, that was the part A. Part B is the Tata Structura H and I sections. So, we thought that H-beam or I-beam, which is normally produced with various steel plants, particularly rolled sections. But what we have introduced, that is plate fabricated section. So it has got certain advantages of welded, we call it factory welded beams as well. So ready to use beams, shorten project time, maintain a clutterless project site, increase productivity, reduce capital expenditure, labor and working minimum, improve safety. So these are, optimal cost and maximum productivity, etc. From that. These are actually sections which we can compare, suppose we have a rolled section, ISMB 600 versus Tata Steel 600. We get, weight almost, to keeping all the properties more or less same or slightly more, we keep it. Yeah. Okay. So it's still 10 to 12% less weight. Okay, main point of the contractor is the procuring of plates, getting inspection, getting qualified welders, rework and rejection, etc. So what we have is a CNC plate cutting machine facilities, and then straightening the plates. And after that, you have automated welding, and it's normally up to 900 millimeter depth beams, but then that is in the automated section. But if it's a fabricated beam, it can go up to even 5 meters. But right now we are doing up to 900. So these are the sizes, which is, and then you have the facility of short blasting and painting. And this is the kind of test certificate what you get. This is the application areas where columns could be hollow sections and I-beams could be in the beams. That is the major saving. So some connections. Then we can offer you castellated beams as well. Yeah, it is possible that, to increase the depth almost 2D, and therefore the properties get enhanced. And tapered castellated beams also possible. Some beginning has happened in the steel buildings. So TC building in Jamshedpur is with this sections. That is. Thank you so much.